In this video, we're going to do some more examples of solving equations that contain radicals. Here we're asked to solve the equation the square root of 3x plus 1 equals x. Remember, the first step to solving any equation that contains a radical is to isolate the radical first. In this equation, we can see on the left that the radical is not isolated. There's an additional term of plus 1 that we need to move over to the right side of the equation first so that we can isolate the radical. So let's start by subtracting 1 from both sides of this equation. Subtracting 1 from the left gives us the square root of 3x plus 1, and subtracting 1 from the right gives us x minus 1. Now that the radical is isolated on the left side, let's undo the square root by squaring both sides of the equation. Squaring the square root on the left side leaves us with 3x plus 1. And on the right side of the equation, we need to square the binomial x minus 1. That means we need to multiply x minus 1 times itself. So we'll have x minus 1 times x minus 1. That's a FOIL situation. And when we FOIL x minus 1 times itself, we get x squared minus 2x plus 1. Notice now that we have an equation that no longer contains a radical. This is a quadratic equation because the highest exponent we see on our variable is a 2. We can solve quadratic equations by factoring. So let's start by subtracting 3x from both sides of the equation. That gives us 1 on the left side of the equation and x squared minus 5x plus 1 on the right. Now let's subtract 1 from both sides of the equation to move the term of 1 on the left to the right side of the equation. That gives us 0 equals x squared minus 5x. Now we're ready to solve this equation by factoring. We notice that the right side of the equation has a common factor of x. Factoring a common factor of x from both of the terms on the right side gives us 0 equals x times the difference, x minus 5. Now the right side of our equation is fully factored, so we take each factor and set it equal to 0 and solve for x. That gives us x equals 0 and x minus 5 equals 0. The equation x equals 0 is already solved. So we have a potential solution of x equals 0. And when we solve the equation x minus 5 equals 0, we find that x is equal to 5. So 0 and 5 are our potential solutions. Now the reason I'm calling these potential solutions is because we squared both sides of this equation to get those solutions. Anytime we square both sides of an equation to solve it, that might introduce extraneous solutions. We need to check x equals 0 and x equals 5 to make sure that they both are actual solutions to this equation. They might be, they might not be, but the only way we're going to know for sure is to check them. Let's check x equals 0 first. So everywhere we see x in the original equation, we're going to substitute in 0. That gives us the principal root of 1 plus 1 equals 0. The positive square root of 1 is 1, so we have 1 plus 1 equals 0. Well, that's 2 equals 0. That's a false statement. So that tells us that the potential solution of x equals 0 is an imposter. It's an extraneous solution. So we have to drop it from our list of solutions because it is not a solution to this equation. Now let's check x equals 5. So everywhere we see an x in the original equation, we'll substitute in 5. On the left, that gives us the positive square root of 16 plus 1 equals 5. The positive square root of 16 is 4, and 4 plus 1 equals 5, which means the left side equals the right side. This is a true statement. That means that 5 is the only solution to this equation. In this example, we're asked to solve the cube root of x plus 7 equals 4. This is the first equation that we've had that has a cube root in it rather than a square root. So how do we solve cube root equations? First things first, always make sure that the cube root expression is isolated on one side of the equation. In this equation, the cube root of x plus 7 is already by itself on the left side of the equation, so step 1's done. Now we need to undo the cube root. The operation that undoes a cube root is the cube operation. So we need to raise both sides of this equation to the third power. That gives us the cube root of x plus 7 raised to the third power on the left side of the equation and 4 raised to the third power on the right side of the equation. We know that the cube root raised to the third power will cancel out. That leaves us with x plus 7 on the left is equal to 64 on the right, because 4 to the third power is 64. This is a linear equation, so let's solve it by subtracting 7 from both sides. That gives us a solution of x equals 57. Now remember, because we raised both sides of the equation to an odd power, we don't have to check for extraneous solutions. The solution that we came up with, x equals 57, if we did our math correctly, should be the solution to this equation. Now, while we're not obligated to check for extraneous solutions, it's still probably a good idea to check to make sure that we did our math correctly. So in the original equation, if we substitute back in 57 everywhere we see an x, on the left side of the equation we'll have the cube root of 57 plus 7. The cube root of 57 plus 7 is the cube root of 64, and the cube root of 64 is 4. So that checks. So x equals 57 is the solution to this equation. Alright, last example. Here we need to solve the equation the cube root of x cubed plus 26 minus 2 equals x. First thing we need to do is isolate the cube root on the left side of the equation. So let's add 2 to both sides of this equation. Adding 2 to the left leaves us with the cube root of x cubed plus 26, and adding 2 to the right gives us x plus 2. Now the radical is isolated on the left side of the equation, so let's undo the cube root by raising both sides of the equation to the third power. So that gives us on the left the cube root of x cubed plus 26 raised to the third power is equal to the sum x plus 2 raised to the third power on the right side of the equation. The cube root cancels out with the exponent of 3 on the left, and that leaves us with x to the third plus 26. And then on the right, we have to multiply x plus 2 times itself 3 times. So that's equivalent to x plus 2 times x plus 2 times x plus 2, which means we need to FOIL x plus 2 times x plus 2, and then take that result and multiply it by x plus 2 again. So on the right side, we'll have x plus 2 times the product x plus 2 times x plus 2. When we FOIL x plus 2 times x plus 2, we get x squared plus 4x plus 4. Now we need to multiply x plus 2 times x squared plus 4x plus 4. X times x squared gives us x to the third. X times 4x gives us 4x squared. And x times 4 gives us 4x. Now we multiply 2 by x squared plus 4x plus 4. 2 times x squared is 2x squared. 2 times 4x is 8x. And 2 times 4 is 8. Now let's clean up the right side of this equation by combining like terms. On the right, bring down the term of x cubed, and then combine 4x squared with 2x squared to get 6x squared. Now we'll combine the terms of 4x and 8x to get 12x, and bring down the constant of 8. Now let's start the process of solving this crazy looking equation. I notice that we have a term of x to the third on the left and a term of x to the third on the right. That means if we subtract x to the third from both sides of the equation, the x to the third on the left goes away and the x to the third on the right goes away. That leaves us with 26 equals 6x squared plus 12x plus 8. This is a quadratic equation. So let's solve it by factoring. First step, subtract 26 from both sides of the equation. Doing that gives us the equation 0 equals 6x squared plus 12x minus 18. Now that all of our terms are on one side of the equation and zeros on the other side, let's factor the right side to solve this equation. Each term on the right can be divided by 6. So let's factor out the GCF of 6. That gives us 6 times the quantity x squared plus 2x minus 3. And now the quantity x squared plus 2x minus 3 can be factored into x plus 3 times x minus 1. Now we take each factor that contains a variable, set it equal to 0, and solve for x. That gives us x plus 3 equals 0 and x minus 1 equals 0. Solving both of those equations for x gives us x equals -3 and 1. And because we solved this equation by raising both sides of the equation to the third power, we won't have any extraneous solutions. So if we did our math correct, x equals -3 and x equals 1 should be the solutions to this equation. But again, it's not a bad idea to check just to make sure. All right, I checked in the background. X equals -3 and x equals 1 both make the equation true. So both of these are the solutions to this equation.